For over 30 years, one incredible machine changed the future of space exploration. It launched like a rocket, lived in space like a spacecraft, and landed like an airplane. This was NASA's legendary Space Shuttle. Although it looks like a single spacecraft, the Space Shuttle is actually made of 3 major vehicles working together during launch. The orbiter carried astronauts, the giant orange tank stored fuel, and the 2 solid rocket boosters produced the enormous power needed to leave Earth. Before every mission, thousands of engineers spent months carefully inspecting every bolt, wire, engine, and computer to ensure the shuttle was ready for space. After assembly, the entire launch system slowly traveled to the launch pad. Moving at less than 2 kilometers per hour, this journey took several hours before the countdown could begin. Launch day has arrived. The shuttle is fully fueled with nearly 2 million liters of super-cold propellant. Every system is checked one final time as engineers begin the last countdown toward liftoff. 6 seconds before liftoff, the shuttle's 3 powerful main engines ignite one at a time. Together they produce more than 1.5 million pounds of thrust before the boosters even fire. Then, in a fraction of a second, both solid rocket boosters ignite. Together they generate over 5 million pounds of thrust, pushing the entire shuttle toward space. Within seconds, the shuttle races higher and faster. It burns thousands of kilograms of fuel every second as it punches through Earth's atmosphere. About 1 minute after launch, the shuttle passes through Max Q, the point of greatest aerodynamic stress. Once safely beyond it, the climb toward orbit continues even faster. Just 2 minutes after launch, the solid rocket boosters have burned all of their fuel. They separate from the shuttle and begin falling back toward Earth, where they will be recovered and reused. Massive parachutes slow the boosters before they splash into the Atlantic Ocean. Recovery teams later tow them back to shore for inspection and refurbishment. Now powered only by its 3 main engines, the shuttle continues climbing. Every second, it moves faster while consuming enormous amounts of liquid hydrogen and liquid oxygen from the external tank. 8.5 minutes after liftoff, the external fuel tank is empty. It separates from the orbiter and later burns up harmlessly in Earth's atmosphere. The shuttle has reached orbit, traveling at nearly 28,000 kilometers per hour. Here, astronauts can begin their mission, whether deploying satellites, conducting experiments, or helping build the International Space Station. Unlike ordinary spacecraft, the Space Shuttle carried a massive cargo bay. This allowed astronauts to transport satellites, scientific laboratories, and even large sections of the International Space Station. One of the shuttle's most valuable tools was its robotic arm. It could carefully move satellites weighing several tons with incredible precision. Over its lifetime, the Space Shuttle successfully deployed dozens of satellites that improved communication, weather forecasting, navigation, and scientific research around the world. The shuttle also made complex spacewalks possible. Astronauts repaired satellites, installed new equipment, and completed missions that could never be performed from Earth. In its later years, the Space Shuttle became essential for building the International Space Station. Without its massive cargo capacity, assembling humanity's largest space laboratory would have been nearly impossible. With its mission complete, the shuttle prepares for the journey home. The payload bay doors close, protecting vital systems before the spacecraft leaves orbit. To begin its return, the shuttle performs a precise deorbit burn. This short engine firing slows the spacecraft just enough for Earth's gravity to pull it back into the atmosphere. As the shuttle plunges back into the atmosphere at more than 27,000 kilometers per hour, friction with the air creates temperatures hotter than molten lava. Special heat-resistant tiles protect the orbiter from temperatures exceeding 1,500 degrees Celsius. Without this thermal shield, the spacecraft would not survive re-entry. As the shuttle slows, the intense plasma fades away. Now flying like a giant glider, it begins the final approach toward the runway with only one chance to land safely. Unlike ordinary aircraft, the Space Shuttle has no engines during landing. From this moment on, it is simply a giant glider, and the pilots have only one opportunity to reach the runway. Only seconds before touchdown, the landing gear deploys. There is no second attempt. Everything must work perfectly on the very first try. After traveling millions of kilometers through space, the shuttle gently touches down. The main landing gear absorbs the impact as the orbiter races down the runway. A large drag parachute opens behind the orbiter, helping reduce speed. Moments later, the shuttle rolls to a complete stop, ending another successful mission. From roaring into space to gliding back home, the Space Shuttle remains one of the greatest engineering achievements in human history. Its legacy continues to inspire the next generation of spacecraft and the explorers who will dream to live in the universe.